that is operator overloading, because that's what I wanted you to practice in today's lab. So operator overloading, as you can see here, you already sort of seen that we are overloading assignment operator, and it is contextually defined for different objects, right? So likewise, when you are doing A plus B, right? This is equivalent to, so A and B here, let's say they are of type class A, right? They are objects of type class A. This is equivalent to writing A dot operator plus, okay, parenthesis passing in B, or it could be operator plus passing in A comma B. You understand this? So in other words, this operator can be either a member function or it can be a non-member function. Non-member means it's outside the class. Okay. So then this allows for chaining of operation. So when we do x plus y plus z, let's say, so this is equivalent to basically saying, let's say x plus y, right, plus z. So then this is going to be equivalent to calling x dot operator plus, right, x dot operator plus passing in y, and then on top of that, whatever this returns, right, because then this has to return an object of the type A, right? And then on that, you're calling operator plus passing in z. Okay, is that clear? So therefore the signature for this plus operator naturally is going to be A, okay, then operator plus passing in const ampersand, sorry, const A ampersand other. I just want to be clear because there is a space between, you cannot just put them together. So this is going to be the signature for this when you are, so it has to return value, and whatever is returned, right, on that now you can call this. So we're going to practice this a little bit. And the difference between this add operation and the assignment operation is that in the case of assignment operation, we saw it was passed by reference. So when you are overloading the operator, you need to know how the signature by default is, only then you can overload, right? So this is going to be const A ampersand other. So it looks exactly like the assignment operator, only difference is that it does not have pass by reference, it passes by value. Okay, let's give another example of operator overloading. So this is standard input. So for standard input, so standard input is derived from standard library. So cin greater than. So when you're writing this, x greater than y, right? So here in this case, you're reading the values x and then followed by y. This is going to be equivalent to writing operator greater than. So here, this is the operator that we are overloading. And we are passing in std : cin as the first argument, right? And the second argument is x, okay? And then whatever this returns, right? that acts as the first argument for operator greater than passing in y. Okay. So in other words, you can see essentially this x applied here and this one is applied here because that's the order in which we are reading. Therefore, this better return C in for me so that I can progress forward, right? So we're going to therefore say the signature here for this therefore is going to be std : I stream. So I stream ampersand. Why? Because we have to modify the stream in this case, right? Because we are reading. Sorry, not modify, but we don't want to have the copy incurred here, and that's the reason we are putting an ampersand here. It's passed by reference. So operator greater than, and then pass in std : I stream ampersand s, and then you have your value that you are actually reading into. So therefore, it's going to be a ampersand a. Any question on this particular thing?
I'm kind of confused about the bigger picture of like where all of this fits in for the operator overloading.
Right. So the bigger picture where it's going to fit in is that when you have overloaded this, right, you can basically write straight away. Suppose I have a, right? You can write like this. So typically, if you have an int x and you wrote c of n, right? And you write c in greater than x, right? So we don't need any definition for it. The standard cin knows how to read into x, the built-in data types, right? But it's a class you have defined, and therefore what to read in you can control by overwriting this greater than operator. And likewise, the plus operator, if these are objects of some class, you can control what does that plus mean in that realm. Like for example, you have defined an array of variables, array of integers. So you can override the plus functionality to do the addition over the array. But there is no addition defined for the objects that, for the class that you are defining, right? Is the context clear? Why you would like to do?
Yeah, I guess.
So we're going to practice this, okay? We're going to practice this. It will become more clear. I'm just laying this down just so that you can refer to it. And likewise, the standard output, which is essentially std : C out. So here we write generally C out less than x less than y, right? That means that from the variable we want to output into the output stream, right? So for the standard output, it's going to be std : O stream, because it's the output stream, ampersand, and then you have operator less than, and then you have std : O stream ampersand s, and notice that here this is going to be a const a ampersand A, because you are actually reading from here and then putting into the cout. And therefore, we don't want the writing into the stream, output stream, to change the value. And therefore, this is constant. But when you are reading it, you are actually changing the value, right? Because you're reading into this. And therefore, you want it to be changed. And therefore, this does not have a const. Any questions so far? I'm probably going too fast. But you're going to practice this. So this is going to become more clear as you practice, okay? So likewise, you can override prefix and postfix operators also. So prefix, postfix operators are like when we do plus plus x. So there, the plus plus x is essentially equivalent to writing x dot operator plus plus this. And then when you write x plus plus, this is equivalent to saying x dot operator plus plus. Now, because both carry plus plus, right? So it has to have something to distinguish. So it just passes a nonsensical value 0. So 0 here is kind of irrelevant, but it just distinguishes the signature of this plus plus from this plus plus. Like one is a prefix, another is a postfix plus plus operator. Okay, so if you have to overwrite, basically you overwrite these signatures. So it essentially, the signatures would look like this: A ampersand operator plus plus. This is for the prefix operator. And then you have your increment logic for whatever makes sense for A. And then you do return star this. And likewise for so this is for the prefix. For the postfix, it's going to be A ampersand operator plus plus, and it carries an int here just to distinguish. And here, so this postfix, because it has to, we don't want this to be kind of, there is one difference here, is that we don't want the postfix operator to be chained, and therefore this does not have an ampersand here in the return value. So here we will be writing a result and then star this. This is the copy constructor that gets invoked, and then you do plus plus star this. So this is basically invoking the prefix operator, and then you return the result. Now, I'm just giving you how the typical implementation would look like, okay? Because in this case, for the postfix, what you want is that you want to first operate, right? You want to first get the copy happen, right? Before incrementing. And then you want to increment the corresponding value. So therefore, the return value here is the original value, but here you're incrementing and then returning it, and therefore you're applying essentially first increment and then return. Okay. Any questions so far? You're going to see these examples in the code that is given to you. I'm just providing you so that you have a reference point when you're reading the code and don't get scared about what you see there. Okay, just one more last thing, which is subscripting. So subscripting would look like this: AA, and then you have member type, let's say M, okay, and you write essentially A of I is equal to M, right? So this is equivalent to writing A dot operator bracket bracket passing in I equal to M. And if you write const A, and then you do A of I equal to M, then this is going to be illegal. Okay, so now let's see how the signature would look like for this. This is the last one. I'm showing how the operator overloading looks like. So it's going to be const member type ampersand operator bracket bracket. Okay, this is going to take int index, and here this function ends with a const, because you do not want it to actually change anything in the case when the const is defined. So there are two functions that have to be defined. One that is a const function, which does not allow for the modification to happen, and another is a non-constant version, which is the member type member type ampersand, then operator bracket bracket int index. So here this is not const, so here the receiver is a const, here the receiver is not const. So you can see here when you're doing A of I equal to M, right, the receiver in this case is a const, so it's going to invoke this particular function. When the receiver is a non-const, it's going to invoke this particular function. Okay, so if you are not following so far in this section, I promise you, it will become clear as you get your hands dirty.